How to avoid redundant circuit analysis equations. Are you tired of writing the same circuit analysis equations over and over? Let's talk about how to avoid redundancy in your work, especially when using Kirchhoff's laws. Understanding these laws is key to efficient circuit analysis. Kirchhoff's current law states that the total current entering a junction must equal the total current leaving it. Meanwhile, Kirchhoff's voltage law tells us that the sum of all voltage changes around a closed loop must equal 0. To keep your equations streamlined, start by identifying independent loops and nodes. An independent loop contains at least one branch not found in any other loop. For nodes, focus on essential ones where 3 or more components connect. Avoid writing equations for every loop or node, as many will simply repeat others. Next, consider using systematic methods like the node voltage method or the mesh current method. These approaches help you focus on independent variables, automatically reducing redundancy. For instance, in the node voltage method, you write equations only for essential nodes. In the mesh current method, you only write equations for independent loops. Be mindful of circuit elements that can lead to redundancy. For example, a current source in parallel with an ideal voltage source or a voltage source in series with an ideal current source can often be simplified. Removing or simplifying these elements can streamline your analysis without losing important information. Circuit simplification is another effective strategy. Combine series and parallel resistors or eliminate redundant elements before writing your equations. This will reduce the number of variables and equations you need to handle. After forming your equations, check for dependencies. Analyze them to see if any are linear combinations of others. If you find dependent equations, remove them to make your solving process more efficient. In circuits with chains of voltage sources, consider replacing voltage sources with short circuits. This can help you identify if the circuit can be split into simpler parts. By focusing on just the part with the variables you care about, you can avoid writing unnecessary equations. In practical terms, avoiding redundant equations saves both time and computational resources. This is especially helpful in complex circuits. It also minimizes the chance of errors in manual calculations and improves clarity when using software tools for circuit analysis. Mastering how to select independent loops and nodes, along with simplifying circuits, is essential for effective circuit analysis.